Hello guys, welcome back to our exploration of cutting-edge technology of today's computational world. And in this video we will deep dive into another fascinating world, and this world is the world of computer clusters and their role in high performance computing. I'm your host, Manoj, and in this video we'll take a closer look into the anatomy of a computer cluster. We'll talk about a brief history, the advantages of computer clusters, and much more related to this topic. So if you guys, once again, are interested in videos like these and want me to keep bringing them, please give my channel a subscribe. In the past, the tasks that require high performance computing with the extremely large datasets were handled by massive standalone supercomputer which had specialized hardware vastly different than the ones found in home or office computers. Today, however, these extremely large computational tasks are handled by computer clusters. And in these computer clusters, each individual computer is referred to as a node. These nodes work together to tackle computationally intensive tasks. Now let's further talk about the anatomy of a cluster, or a computer cluster to be more exact. Each individual, like I said, computer in the computer cluster is referred to as a node. The head node, also known as the master node, serves as a central point for control of the cluster. So basically, it is essentially something that directs the commands to other nodes. It manages and coordinates the activities of compute nodes. Now let's talk about a compute node. Compute node or compute node, since there'll be a lot of them, since there's only usually there'll be singular head node, but there are many compute nodes. That is why it's a big cluster, and compute nodes are responsible for performing the actual computations within the cluster. They handle tasks and execute parallelized algorithm. So algorithms where we have tasks working in parallel. For example, and this is very simple, multi-threading. Imagine you have like a program that performs calculation over massive numbers. And if you run a simple one-thread program, it will take forever. So we break down the problem into multiple sub-problems, and we're handling them in parallel over multiple parts on the CPU or threads. That is one form of parallel processing. So in the high-performance computing, where we have multiple nodes, the huge tasks are handled parallelized with parallelized algorithms. And then there's cores. Cores refer to the individual processing units within a node's CPU, because each node is basically a computer, or it's practically a computer. Modern CPUs commonly feature multiple cores. For example, the Core i7, usually depending on which generation you buy, you would see like 8 cores, 16 cores, even 32 cores. Nowadays even 64 cores. We keep getting higher and higher. Can we get much higher? Although the parallel processing has actually increased computational power. Now let's talk about, and again we'll be brief about it, and I can talk a lot more about this in the future topics. You guys have to let me know if you guys like these kind of videos. But the clusters offer several advantages, including scalability. One of the biggest advantages is that it is a lot more scalable to have a computer cluster handling huge high-performance computing intensive tasks over a cloud-based technology like an AWS or Azure. And then one more is obviously cost effectiveness. A huge task that requires high-performance computing or extremely humongous data would be significantly more cost-effective than using a cloud-based technology service like AWS. And since the organization itself owns or usually rents a computer cluster, it offers them significantly more flexibility than a cloud-based technology would. Anyways, let's talk a bit more in detail about the background and history of computer clusters. To understand the significance of computer clusters, let's take a journey back in time. The concept of clustering dates back to late 1970s when DataPoint developed ARCnet, the first commercial computer cluster. However, it wasn't until 1984 when Digital Equipment Corporation introduced VAXcluster and VAX/VMS operating system to go along with it. Now ARCnet and VAX not only supported parallel computing, they also shared file systems, peripheral devices, aiming to provide the advantages of parallel processing while maintaining data reliability and uniqueness. Now, let's actually jump ahead in the time. The evolution of computer clusters continued with notable products like Tandem Himalaya and IBM S390 parallel Sysplex in the mid-1990s, catering to high availability and business use respectively. However, a pivotal moment in the history of computer clusters came in 1989 with development of parallel virtual machine (PVM) software. PVM was an open source software based on TCP/IP communications, and it enabled the creation of virtual supercomputers using any TCP/IP connected systems. Now I must say that was huge because that breakthrough actually led to a NASA project in 1993 to build supercomputers out of commodity clusters. In 1995, the ever popular, at least among this community, I'm sure like normal people wouldn't know about this, but people who actually have been learning about clusters know about this. The Beowulf cluster was invented, sparking the independent development of grid computing. Now, since the clusters offer a great deal of advantages, it has incredible usage in the different industries across the world. We can talk about domains that include scientific research in biology, chemistry, physics. There's a topic called Bioinformatics, which actually uses high performance computing, and the use of clusters in that domain is pretty significant. It is used in the financial sector, in weather forecasting, artificial intelligence, video gaming, the graphical rendering, and bunch of different tasks. Again, that in itself sounds like a video of its own. Let me know if you guys want it. So, with that all said, this was meant to be a brief overview. I do not want this to be a 30-minute long video because I know you guys will be bored. So I would conclude that by saying that clusters represent a versatile and cost-effective approach to high-performance computing. With the ability to scale, the flexibility, and wide-ranging applications, clusters have become indispensable tool to tackle complex computational tasks across various industries. With that said, I want to thank you guys once again for tuning in. If you guys like what I do and want this channel to grow and me keep producing these kind of videos and more, like, share, and subscribe. Until next video, have a nice day.